Welcome to Study Loop.
This is chapter 27, problem number 8. We have a point charge that has a magnetic field acting on it. The magnetic field vector is given to us as negative 1.25 k hat. And the magnetic force acting on it is given to us also in the vector form, 3.4 times 10 to the negative 7 I hat plus 7.4 times 10 to the power negative 7 j hat. And from this information, also the charge is given to us, which is negative 5.6 nanocoulombs. Let's do the conversion while we're at it. It's going to be negative 10 to the power negative 9 coulombs. Now, in order to calculate the velocity vector, given that information, we're going to remember F equals QV cross B. So then Q equals I hat, J hat, K hat, B sub X, V sub Y, B sub Z, B sub X, B sub Y, and B sub Z. As you know, these two components are zero because magnetic field is given purely along X direction. So it's negative 1.25. Now let's plug it in for Q, negative 5.6 times 10 to the power negative 9. Now I hat V sub Y times negative 1.25, negative 1.25 V sub Y minus 0 minus J hat. It's going to be negative 1.25 V sub X minus 0 plus K hat, 0 minus 0. Right. So this entire thing, which is force, is given to us already. So we know the right-hand side to be negative 3.4 times 10 to the power negative 7 I hat plus 7.4 times 10 to the negative 7 j hat. So the first term, the component of I hat, is going to be equal to this term. And the j hat's component is going to be equal to the j hat's component. So let's write them down here. Negative 5.6 times 10 to the negative 9 times 1.25 is going to give us 7 times 10 to the power negative 9 V sub Y for the first term. So that has to be equal to negative 3.4 times 10 to the power negative 7. So from here, V sub Y is going to be equal to negative 48.6 meters per second. So when we do the same for the j hat, the component of the j hat, we get negative 7 times 10 to the power of negative 9 times V sub X equals 7.4 times 10 to the power of negative 7. From here, V sub X is going to be equal to negative 105.7 meters per second. So at the end, we can write the velocity vector in terms of the components, negative 105 times 7 I hat minus 48.6 j hat. Now in part B, let's go to a new page. In part B, we're asked whether or not there's a component of the velocity vector that cannot be determined given the information. As you can see, our velocity vector is given, well, the components of the velocity vector is x and along x and y directions. We don't know any information about v sub z, so we cannot determine v sub z. So there's no actually force due to z component of the velocity vector, v vector, along the direction of the magnetic field. So in this case, measurement of the force vector tells us nothing about v sub z. So in part C, we are to calculate the dot product F. So if we just copy our velocity vector, so 105.7 I hat minus 48.6 j hat dot product negative 3.4 times 10 to the power of negative 7 I hat plus 7.4 times 10 to the power of negative 7 j hat. So the multiplication of the components of I hat, we're going to get 3.6 times 10 to the power of negative 5. And then from the second term, we're going to get the same number, only this time we have negative of it. As you can see, this equals to 0. As you know, this dot product means the magnitude of the first vector, magnitude of the second vector, and the cosine of the angle between the two. We know that v is non-zero and f is non-zero, so the only other option that we have is cosine theta equals 0. And you can get that when your theta is actually 90 degrees, because cosine 90 gives you 0, which means the angle between the velocity vector and the force vector is 90 degrees. So velocity vector is perpendicular to force.